Hello everyone, welcome back to Mr. Martin's Math for British Columbia Math 9. Today we are looking at notes from section 4.4, which is multiplying polynomials by monomials. Okay, so by the end of this class, you should be able to use multiple strategies to multiply polynomials by a monomial and solve problems including multiplication of a polynomial by a binomial, so word problems. Last day we looked at how to multiply a monomial by a monomial. All right, you can look at the previous video posted on the channel. Today we're going to be looking at how to multiply a monomial by a polynomial. All right, so we're kind of upping the ante here a little bit using something called the distributive property. All right, very important concept in math here, and we did refer to it a little bit when we were subtracting polynomials. How I said we would distribute that -1 into the polynomial that you were subtracting. So essentially, this is what we were doing then. Okay, so for the distributive property, we recall the distributive property of numbers that you learned in grade 8 math. So you do have some recollection of this, hopefully from grade 8 math, where when you have a number, something like this, where a is multiplied times b plus c, what it actually turns into is a times b plus a times c. Okay, so you're distributing, and I always use arrows to kind of demonstrate the distribution here. A is going to be multiplied to both b and c. Okay, so a kind of represents my monomial, and the b plus c represents my polynomial. So the term outside of the brackets needs to multiply to each of the terms inside of the brackets. Okay, so let's look at some examples. All right, because this is actually a very useful way of looking at solving for different questions and different numbers. So we're going to calculate each product using a distributive property. Actually, real quick before we do this, here we're going to look into here. The actual is actually a really useful way to multiply two-digit numbers together. Okay, so sometimes if I were to give you a question like 5 times 47, right? That might not be necessarily a very easy answer to get right off the bat. Okay, obviously you can probably figure out pretty quick, but sometimes representing a number like this as 5 times 40 plus 7, right? Which would break down into 5 times 40 plus 5 times 7. Oops, that's not a 7. 7, right? Using the distributive property, the 5 times the 40, and then the 5 multiplies to the 7. And then that would give you 5 times 40 is 200, and 5 times 7 is 35, which would give you an answer of 235, right? So it's actually a helpful way to multiply just regular numbers without variables, but also can be utilized with variables as well. All right, so let's look at examples of polynomials and monomials together. So here we have our first example of 3x times 2x plus 4. Okay, the first couple ones I'm going to be showing kind of every little step, but eventually, as you'll see, you'll get better and better at this. You won't have to show all of the steps that I'm showing, and I'll be reducing the amount of steps that I'm going to be showing as we go through some of these questions. Okay, and so 3x times 2x plus 4. So of course I know that I have to multiply my monomial with each term of my polynomial. So 3x times 2x plus 3x times 4, right? That's what we end up with, right? The 3x times the 2x and the 3x times the 4, all right? And then the 3x times the 2x, if you guys remember, you multiply the coefficients together and then the variables together. That's from last set of notes. And so I get 3 times 2 is 6. X times x is x squared. Plus 3 times 4 is 12. And then 12x. X times 1 essentially is just x. And that would be your answer. Okay? Next question here, negative 4a times 6 minus a. Okay, so this negative 4a is my monomial, and it's going to multiply to both terms in my polynomial. So I'm going to get negative 4a times 6 minus negative 4a times a. All right. And so here, negative 4a times 6 is going to give me negative 24a. And then here, give me a minus. The negative 4a times a is negative 4a squared. And because I'm minusing a negative, this gives me negative 24a plus a 4a squared. Okay, and ideally I also want to order these by degree. Okay, so I would put the 4a squared in the front and the minus 24a as the second term. Okay, you want to, best practice is you want to order your polynomials by degree of the terms. All right, another one here. I'm going to show one last step here. Now here they kind of switched it up on us a little bit. We're used to the monomial being on the left, the polynomial being on the right. But here, our monomial is not the 2 plus c. It's the c over here, and this is the one that gets distributed to both terms. Okay, so c times c gives me c squared, and then c times 2 gives me 2c, and that would be your answer. Okay. Sometimes here it could be, oftentimes the monomial will be written without brackets, okay? But it's the same thing because they're next to each other. You're assuming that there's brackets between the monomial and the polynomial, and then you're just distributing to both terms. And so 1.4k times 2.9k squared, so the 1.4 times the 2.9 gives me 4.06, and then k to the 1 times k to the 2 gives me k to the 3, and then 1.4k times negative 1 gives me negative 1.4k. That would be my final answer. All right, you notice that I'm providing a few less steps here, okay? But I do want you guys kind of in your mind's eye that you're seeing that when I'm distributing the polynomial, I'm multiplying both terms when I'm distributing the monomial, I'm multiplying the monomial to both terms in the polynomial, okay? But as we, get better at this, the steps that you have to write to ensure that you get the correct answer will probably reduce as you go, where you can just kind of draw your arrows and get your answer pretty quick here. Sometimes, though, when you're dealing with fractions, you still might want to kind of draw out your steps to help you out. And so here, again, our monomial is in the front here, and it's going to be distributed to both terms, okay? And then you want to multiply the coefficients together. So here I have negative 2 over 5. Negative 2 over 5 times the coefficient, right? Coefficient times coefficient, times 3 over 1, which is going to give me negative 6 over 5. And then y times y is y squared, right? So that's the first term. And then I'll do a side calculation here. negative 2 over 5 times negative 4 over 3. That's going to give me positive 8 over 15. So plus 8 over 15, and then it's just the y on that side. Okay, and that would be your final answer. Okay, because you're multiplying here in the second step, we multiplied this coefficient by this coefficient for this second step. All right, you're just multiplying fractions left to right. Give it a shot. Try your turn. Try it on your own. I want you guys to pause the video and try all 6 of these, and then unpause the video and we'll go over them together. All right, hopefully that went well for you. And let's check it out. All right, so here again, and when I'm doing 7x times x, what I need to see in my mind's eye is 7x times x, and then minus 7x times 2, right? Which is going to give me 7x squared minus 14x. Okay, so that's what you have to see, this middle step here. You have to see kind of in your mind's eye. In your mind's eye here when you're distributing that monomial into your polynomial. All right, same thing here. My monomial is the negative 5b, and it's going to be distributed to the first term, which is negative 5b times b, and then distribute it to the second term. So plus negative 5b, times 9, okay? And then this is giving me negative 5b squared, and plus negative 45b, or minus 45b if you want. Okay, same kind of, this can be rewritten as negative 5b squared minus 45b. Either way. Okay. Same thing here, though I'm not going to kind of show that middle step here, but I want you guys to kind of see it. So I do 4f times f squared, which is going to give me 4f cubed, right? Remember those exponent laws? F to the 1 times f to the 2 is equal to f to the 1 plus 2, which is equal to f cubed. Okay, and then 4f times 8 is equal to 32f. Here, my monomial is the one on the left now, so my arrows are going to come from the left and not from the right. Okay, so here I'm going to do 1.3 times 7, 1.3a times 7a squared, and specifically negative 7 here. So 1.3 times negative 7 gives me negative 9.1 a cubed. And then 1.3a times 2, positive 2, would give me 2.6a would be your answer there. Okay. And then here, you have to be willing to multiply fractions as well. So in this situation here, the 4 over 7x times 2x squared. Now here sometimes it's helpful to kind of do the fractions on the side here. So I have 4 over 7 times 2 over 1 is going to give me 8 over 7, right? Top times top, bottom times bottom. So that is 8 over 7, and then x times x cubed, x squared is going to give me x cubed. All right, and then I multiply my monomial by the second fraction there. So my fraction here is still 4 over 7 times negative 9 over 2. And that's going to give me negative 36 divided by 14. And this can be reduced 2. I can divide both the top and the bottom by 2 here, and this would give me negative 18 over 7. All right, and that's as low as I can put it. I can leave it as an improper fraction here. So this is minus 18. That negative becomes a minus 18 over 7, and then that x from the 4 over 7x goes behind that second term. All right. And, oh, what's going on here? This is new. We haven't seen this before. Whatever can we do? So in this situation here, all right, this is kind of an extended question for us. Here we have a polynomial multiplied with a polynomial, okay? Just as the distributive property here for monomial times polynomial, we had to multiply the monomial by each term of the polynomial. When you're multiplying polynomial times polynomial, you have to distribute each term of the first polynomial with each term of the second polynomial. All right, so there's 4 arrows I'm going to draw here. So first I'm going to do the first term of my first polynomial times the first term of my second polynomial, x times x, which is x squared. Next I'm going to do x times 4, which is 4x. All right, so now my first term of my first polynomial has been distributed to both terms of the second polynomial. Next, I want to take my second term in my first polynomial and multiply it to both terms in the second. So positive 3 times x gives me plus 3x, and then 3 times 4 gives me plus 12. Okay, so each term in the first polynomial needs to be multiplied by each term in the second polynomial. All right, so you want to distribute the terms in the first polynomial, the one on the left, drawing 4 arrows to the polynomial on the right. Now I'm not done here because I have some like terms that were created by distributing those terms in the first polynomial. So I want to combine those like terms. I end up with x squared plus 7x plus 12, and that would be your final answer there. Okay, so a bit of an extended question there for you guys. All right, example number 2, how to use these algebra tiles. Oh, these lovely algebra tiles. And so here's just kind of setting up our drawing. We're multiplying, so you set up your grid. Okay, and I have 3x, 1, 2, 3, and then minus 5. 1, 3, 4, 5. Oops. And of course, the 3x are positive 3x, so these have to be shaded. Okay, but the negative 5, those are negatives, right? Those are negative 5 negative 1s. So those are not shaded; they're left open. And then I have 2x on the side. All right. So these are my factors. Okay, now I'm going to draw the boxes inside using the width of the tile on the top and the length of the tile on the side, and then I complete my shape. Same thing here. All right. All right, and I'll fill those in a second because it's positive times positive. So I should be filling in each of these. I'm going to use my highlighter. Speed things up. All right. And then same thing here. I use the width of the top tile and the length of the side tile. And I get a bunch of these tall... Mine are getting shorter and shorter and shorter. Let me try to resist that. So again, the width of the top tile, length of the side tile. And because it's negative times positive, those will stay empty. And so it gives us an answer here. I have 1, 2, 3, 4, 5, 6 positive x squared tiled, 6x squared. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negative tiles. So negative 10x. I have 10 negative x tiles. All right, which is exactly what I would get using algebra, right? 2x times 3x. 2 times 3 is 6. X times x is x squared. 2x times negative 5 is negative 10. And then x right there. Okay, I want you guys to try this one. Okay, so even though there's no your turn kind of section here, I want you guys to pause the video and try this one out on your own. Okay. All right, hopefully that went well. Okay, maybe you had to rewind the YouTube video just to kind of rewatch what we did above here. So here I set it up again, my grid. So I have negative 3x on the top. And here it doesn't matter which one you put on the top or on the side. Negative 3x. And then I have positive 3x on the side here. 1, 2, oops. And then positive 2. Man, okay. 1, 2, 3, 1, 2. And shade these guys in. All right. Oops. I need to not shade the top ones. Okay. Just the side ones. Right? The top ones are negative, so they stay open. Okay. Now again, I use the width of the top tile, the length of the side tile, and I complete my shapes. And got lots of these to draw. Okay, now again, I'm using the width of the top tile and the length of the side tile. Okay, and it gives me these sideways X tiles. Okay, and because all of these are negative times a positive, all of these tiles stay blank, okay, stay unshaded. I have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 negative x squared tiles. I have 9 of those, and I have 1, 2, 3, 4, 5, 6, 6 negative x tiles. So that gives me negative 9x squared minus 6x, which is what we would get by distributing this monomial into both of these, right? Negative 3 times positive 3 is negative 9. X times x is x squared. Negative 3 times 2 is negative 6x. All right, good. Let's apply this to a word problem. The dimensions of a rectangular gym floor are represented by the expression 4x and 5x minus 3. So I'm assuming that the length is 4x and the width is 5x minus 3. Okay, so that's what we're given here. What is a polynomial expression for the area of the gym? Okay, so we know that area is equal to length times width. Okay, so if I want to solve for area, my length is 4x, and my width, I replace w with the 5x minus 3. And you see here that I end up with a situation where I have to multiply a monomial by a binomial. And hopefully now you guys are comfortable with that. I do 4x times 5x gives me 20x squared. And I take that 4x and I distribute it to the negative 3, which gives me negative 12x. And that would be the expression for the area of the floor. Okay? And for B, if the value of x is 3, what is the area of the floor? So in this situation, in the first question A, we didn't know what x was, so this is kind of what we're left with, is an expression to represent the area of the floor. But now they're telling us what x is equal to. They're saying x is equal to 3. So in my equation here, instead of writing x, each time that x shows up in my equation, I'm going to substitute it with 3 in brackets. Okay, and it is important that you put the brackets here because that exponent needs to be applied just to the 3, not to the 3 times 20. Okay, and then here I can plug this into my calculator to get an answer. 3 squared is 9. 9 times 20 is 180. And then minus 3 times 12 minus 36. So the area of the gym floor, I don't know what units they are giving here. They don't tell me the units, so we'll just leave the units blank. So the area of the gym floor is 144, probably meters. We'll say it's 3 meters, and this would be 3 meters squared. Okay, and we can double check our math. 20 squared minus 12 times 3, and sure enough we get 144. So that's our final answer. So hopefully by now, if we check what our initial goals that we started with, you should be able to use multiple strategies here, multiple referring to both the algebra tiles and algebraically. Can you do that? How comfortable are you with that? Hopefully you're a pro, or at least you kind of know what you're doing now. If you have more questions, you can contact me directly, those of you who are my students. Or leave a message in the comments as well, or a like. And then can you solve problems involving multiplications of a polynomial by a monomial? Okay, we did one example in our notes just above here with the floor of the basketball court, but there'll be more examples in your homework assignment as well. All right, your homework assignment is in the bottom here. All right, and the due date will be given to you in the assignment in your Teams app. And we'll see you guys next time.